Hi, in the previous video we calculated the regression equation, and in this video we're going to do the correlation coefficient and the coefficient of determination. And this calculation will complete the whole regression and correlation analysis of our example GDP per capita and life expectancy. Remember, life expectancy is the dependent variable and it depends here on the independent variable GDP per capita. So on bottom left of the screen we have the correlation coefficient formula. Very similar to your B formula. The top of the equation is the very same. The bottom left here is the very same, except there's a square root. And we just introduced this other part on the bottom right of the correlation coefficient formula just to complete things. So again, all of this information was done in the previous video number 5. If you want to go back and take a look at it, I'll link it below. And we just need to follow again the steps in order to calculate OR, known as the correlation coefficient. This will tell us the strength of the relationship between two variables. The maximum value it can have is 1 and the lowest value is 0 if there's a positive relationship, and again if it's a negative relationship between 0 and -1. Closest to the -1 indicates a strong negative relationship, closer to 0 indicates a 0 relationship or no relationship at all. Okay, so again we have your 10 countries, and in the formula we have n, and n is known as 10. So we'll put that value in later on. Sigma is the sum of x by y is your independent variable multiplied by your dependent variable. And again, this information is given to us. The values of x and y are given to us individually for each country. And we'll just multiply those out as we have done here as shown in the previous video. So x by y is your individual x by y values, and these are all done here in Excel. We just show how it's calculated. B2 multiplied by C2. So we do that for each individual country, and we sum up those values. Sum D2 to D11. Okay, so we also are expected to get the sum of x and the sum of y, which we have here. Again, all shown in the previous video. Bottom left, sum x squared, so we need to square your x values. So we square our x values, which is GDP per capita. So you square each individual x value and you sum those up. And now we get the sum of x to be squared, and we'll put all those values in later on. But what I want to draw your attention to here is the y squared value. So in our table, we put in your y squared. Now y squared is just your dependent variable for each country squared. So this is your dependent variable for Angola. So it'll be the cell of the figure power of 2. We can just drag that box down to the last country here, which is Brazil. And then we just sum up the values. So we click on the cell, in this case F2, colon, the last cell we want to include in the calculation, F11. Close your bracket, and we have the sum. So there we have the y squared. Now we have all the values that we can put into our OR formula, and I'm going to tackle the top line. So n is 10. 10 by sum xy. We take the next part of the top line of OR, which is sum x by sum y. So sum of x multiply sum of y. I'm getting the multiply figure here on the number 8 on the keyboard. Okay. So we've the top line done. We'll get to that, complete that calculation soon. So the bottom left, I think I'll put all the calculations in one equation. So square root is SQRT. I'll add some brackets back in later on. So we've again 10 multiply sum x squared, close our bracket, minus sum of x to be squared. Okay, since there's two calculations here, I need to go back and put in our bracket. And we do the very same for the right side of the denominator of the OR equation. So again, our square root. Now I know there's going to be two brackets. 10 multiply your sum of y squared and the sum of y to be squared. Okay, just notice that the sum of y squared is different to the sum of y to be squared. Likewise, the same with x. So now we have our figures that are needed to complete the correlation coefficient calculation. Let's just put them all together and we'll get the OR value. Should be between 0 and 1 since we are here expecting a positive relationship between the two. So the top line first, we have n some xy minus some x times some y. And on the bottom, we're going to multiply these two values that we just calculated. And finally, we'll get our answer when we divide one into the other. And there we have it. 0.5969. Okay, we don't put that as a unit of measurement. Okay, that's just written as a scale, like from 0 to 1. So here, theoretically, we would say that there's a moderately strong positive relationship between the two of them. Closer to 1, the stronger the relationship. Closer to 0, the weaker the relationship. However, empirically, this would be considered an excellent relationship between the two variables. Now, just to go on to calculate the coefficient of determination, to get that coefficient of determination, we just square your value. And we have 0.3564. That can be expressed as a percentage, so it's 35.6%. And it indicates that 35.6% of any movement in the dependent variable, in this case life expectancy, is caused by changes to GDP per capita. So let's go back to video 5 to see what the R squared value was like. And here we have it, the R squared value 0.3564, identical to the value we calculated, but quite easily found using Excel. So thanks for watching, and I'd love for you to subscribe to the Economic Rockstar YouTube channel and check us out on iTunes. I have a fantastic podcast where I interview a lot of great economists and financial analysts.